Okay, I'm going to get started now with the webinar. This webinar is being recorded as well, so if anyone has missed it or wants to see the webinar over again, it will be available later on after the webinar. And when you get the link to the webinar, you'll also get a link to the parts that I've used in the webinar. This way you can check this out as well. Okay, so let's get started. And I'll get rid of the camera so you don't have to see my face. Okay. The first thing I'd like to start out with in SolidCAM 2019 is some of the highlights that we've done, some of the improvements that we've done in 2.5D milling. Now let's start with the multi-depth drilling. This is a completely new operation. Now, this multi-depth drilling gives you full control of your drilling operations at every single depth and every single segment. It's extremely useful for deep holes and for drilling through cross holes, as you can see in the diagram over here as well. Now, the multi-depth drill will give you complete spin control at every single depth, and you can use it for whatever way you feel like using it, whether you want to change your multi-depth speed on the as you're retracting, whatever way you want to use it, you can do it. As not only the speed, I'm sorry, but also the direction. I was talking about the direction, my mistake. The direction can be changed at any single point. And I'll actually demonstrate this a little later on as we go through the webinar. And as I started talking about before, the spin rate and feed rate can also be changed at every single depth, giving you full control of your feed and spin rate.
Cindy, am I the only one who only sees your screen? We only see the ambassador screen.
Thanks. I was going to bring that up.
I'm sorry. There we go. My mistake.
That's a little better.
Okay. Okay. So as I said, we're talking about multi-depth.
First time doing a webinar there, Sid?
What?
First time doing a webinar?
I must be. I'm nervous about this one, you know.
Okay.
How am I doing?
So far, so good.
Okay. So as I mentioned about the multi-depth drilling, and the fact that you have also complete control of your spin direction, and also your complete control of the spin and feed rate at every single depth. Now, also at every single segment, you have complete control also of your pecking. So you can have, and as far as the pecking goes, you can also have it with a gradual step down, or I like to say a decremental step down. This should be decremental, by the way. I'll change that slide later. And as far as your retract, you can even have a full retract, or at the start, retract up to the start of the segment, or a user-defined retract as well, where you can have it go back to the pec clearance level, which you define, and when you go back down, you can go back down up until whatever value you put in over here. So you have complete control of what you want to do inside the operation itself. Let's actually get started, and let's do a little bit of a demonstration here. I'm going to actually load two parts. This first part that I'm going to show you, I've already programmed it, and I'm just going to show you how it looks inside after it's programmed. And the second part, I'm going to do a quick programming and show you how to program it. I'm not going to go too deep into it, but you'll see exactly how this works. Now, what I'm doing in this part is as follows. This part in itself is, if I show you the section view, you can see that we have 3 through holes going all the way down to the bottom. Not necessarily a deep drilling part. However, you have cross holes over here that are going across. So there are times you would like to actually control this. You like to go straight from here directly down to this area over here, and then continue drilling on down to here, and then rapid down to here, and then further on down over there. And the same thing with the rest of the part itself. So let's actually take a look at the operation that I've created over here. As you can see, the geometry itself are those 3 points, those 3 holes. The drill that I'll be using will be a standard 6mm drill, which is roughly a 1/4 inch drill. The levels, which I'm going down all the way to the very bottom, will be 150mm, which is roughly approximately 6 inches deep. And I'll be going to the full diameter of the drill. In other words, a little more than 150, about 152mm. Now, here's where everything comes together in the technology. It looks a little full over here, but let me explain exactly what's going on here. When you open this up the very first time, all you'll see are 2 values over here. You'll see the actual safety distance at the very beginning and the total depth at the end. Now, what I've done here in this particular case is as follows. I've told it, okay, at 2mm, I want you to go there at a rate of 2,000 millimeters per minute, but I turned off my spin rate, my spin. And I also turned off the coolant, and there's no dwell involved over here. Now, my next segment, going down to -33, it's going at a feed rate of 600, at a spin rate of 3,500, and clockwise. My coolant is turned on, and my dwell is on. And note at the bottom, I have my PEC on as well for segment level 2. Because you can control the PEC for every single segment. It can be different. And in this particular case, my step down is every 4mm. Then it's decrementing down at 1mm. So it's going to go 4, 3, 2 until my minimum of 1mm. Now, when the release distance, I decided to use the PEC clearance level. So it's going to go up 1mm after each time, after each one of these step downs, and then go back down to 0.1mm before that step down. And in addition, I've also added a dwell at the end of each step down. And then I've gone down further over here to -70 to go down this area to take down this area over there. And in this particular case, you'll note I don't have a PEC, and I've also sped up the feed rate. Okay? There are people that may even turn off the coolant in this particular case. I didn't, but you can if you want to. Basically, you can do anything you want. And then I did the same thing for the next area over here, and then down to the very bottom. Going back up, just to show that I can, I decided, okay, I'm going to go counterclockwise and at a faster feed rate. And then I'm going to leave it. I'm going to turn off my spin direction. Okay. Just to show you a quick simulation of what I've done over here. We'll do it one step at a time. Let's do solid verify. You can see the tool is actually pecking its way down. Let me make this extra so you can see a little bit through the part itself. And as it's going down, you'll see it's going to break through material over there, right through there, and then it's going to jump all the way down to the next hole. And this is continuing down all the way down to the bottom. Same thing here, jumps down, and then it does the same in the next one as well. Now what I'm going to do is I'm going to change the part, and then I'm going to just give a little bit of a programming of the part itself. So if I'm going to open up a part, let's open up this part over here. Now this part that I'm opening up is a typical case of a deep drilling hole. If I show my partial view over here, you'll see that I have these two holes going all the way down to the bottom over here. And this is approximately 250 millimeters, if I remember correctly. Now, what I've done here is I've done the following. I've already created a spot drill to go down and create a spot drill on top. And I did a preliminary drilling operation to go down as far as I can with a regular drill. In this particular case, I went down to a regular level, it's my regular drilling operation of 100 millimeters. So now I'm going to start my multi-depth drilling. And I'll choose my geometry, which I already have over there, those two holes. The tool that I'll be using a long drill this time. This drill over here, which is outside the holder of 275 millimeters. And as you can see, my levels is at 250 millimeters, and I'm going to have it go full diameter. Now here we go to our technology. As you can see, when we start, this is exactly what we have. We have the levels, the safety distance, and just the very end. I'm going to take off the dwell for this. I'm going to leave this on over here. And at this point, I'm going to turn off my spin rate. My spin direction as well. When I turn it off, my spin goes to 0. I'm going to change this to rapid. Okay, I'm outside. I want to get to a specific area. Okay, now I want to add another step to this. Adding another step can be done two ways, either by right-clicking and adding, or just simply click on the add button at the bottom. So I'm over here, going to add a step. I'm going to put in the value. Now the value I'm going to put in here right now is minus 5 millimeters, just past the beginning of the actual hole itself. I'm going to go in at a feed rate of 300. I'm going to leave it. And I'm going to still keep my spin rate at off. Since this is a long drill, if I would start spinning it outside of the hole itself, the drill would start throwing itself all over the place, and we don't want to have that. So I'm going to turn off my spin rate. And obviously, I'm not doing any pecking at this moment. And I do not need a dwell. Okay? I may even turn off my coolant if I don't want to have it on. Same thing over here. Okay, my next step, after my minus 5, I'm going to go now to minus 99, about 1 millimeter above where I drilled down before too. Okay? I'll have my spin rate go on now. I'll put on a feed rate of, say, 1,000. I'm bold. And I'll put my coolant on. Some people, I've noticed also, they've mentioned this, is that when they're going down in that first area over there, they actually like working counterclockwise. So I'll actually start this off counterclockwise up until I get to that point. Now I'm going to add my next step. My next step, I'm going to actually leave it exactly where it is right now. Clockwise. I'm going to do a peck over here. And say I'm going to do a peck of every 6 millimeters. Decrement by 0.5 millimeters. And then have a minimum step down of, say, 1 millimeter. So it's going to start 6, 5.5, 5, 4.5, 4, up until it gets to 1 millimeter. Now my retract, I'm going to have it go to my peck clearance level, up 2 millimeters every time, or leave it at 1 millimeter, and this I'm going to have it at 0.1. Now, obviously I can add more steps in there if I want in between it, but I'm not going to. The only thing I'm going to do now is at the very end, is I'm going to add another step. I'm going to go back up to minus 5. Okay, I'm going to do that at a rate of 1,000. And I may even, I'm going to turn off my dwell. I don't need a dwell here. That's dwell over there I do need, but this dwell I don't need. And that dwell I also don't need. My coolant, leave it on or off. Everyone can decide exactly how they want. Some people may even take it further and say, you know what, when I go out, I want to turn it counterclockwise. Again, I'm not talking, everyone can have their own way of doing it. I'm just showing you that you have complete control of what you want to do over here. If I go now to my next step, I'm going to add just one more step here. I'm going to have it at 2 millimeters. I'm going to have this also at a feed rate of 1,000. And I'm going to turn off my feed, because now I'm leaving the material. So when I leave it, I don't want to have a spin rate. So that my drill doesn't go flying all over the place. Okay, do not need this. I can turn off my coolant over here as well, and then save and calculate. Okay, now, running a simulation on this, you'll see the drill going down, and now it's at minus 11, sorry. Okay, my mistake. I say I made a peck over there. No problem. I'm going to go to this one over here. I forgot to turn the peck off for this one. And I put it on this one instead. That's what we have simulation for. Okay, 0.5. Minimum of 1 millimeter. And we'll save it now. Run my simulation. Again, my first step is going to go all the way down, as you just saw, to minus 1. So minus 99. And now it's going to start pecking all the way down to the very bottom. As you see, it takes smaller and smaller steps up until it's staying now at a step rate of every 1 millimeter. Going down to the bottom. Now it's going to go back up. You see, it's still inside the material. You can see my feed rate and spin rate. My spin turned to 0. Now it's going over to the next hole. You'll note that my spin rate is still at 0. And now it's going to start again. And that's how it actually starts finishing off the entire part. Now, if you're asking about the G code on this, this is a non-cycle drilling operation. Your G code will be all linear movements, whether it be G1 or G0. Everything will be exactly according to those. There's no cycles in this at all. So this does not make a difference what machine you're on, because it's not using a cycle. It's just using regular linear code for this. Okay. Next.
Sydney.
Yes.
Is this just considered an enhancement, or is this considered something that we could sell as a module, the multi-dev?
Well, you can sell it if you want to. Well, the reason, and right now it has a separate license on it as well. And the reason for that is also because there must be a fix in the post in order for this to work correctly.
Okay, so it sounds like that would be a separate module, especially if going forward, is that going to be in every, I suppose we need to think about it, but is that going to be in every post, or is that just something that, like Machine Sim, where we have to set up the post when they buy it?
If they buy, they just have to change that. I would imagine just changing it, making a change in a post.
Okay, so it definitely sounds like it's not just a regular enhancement.
No, this is a new operation.
Cool.
Okay. Okay, let's go on to our next. We've made now enhancements also as well in our face mill. We've added a new option for creating a geometry based on the updated stock boundary of the part. As we all know, almost most of the time when you're actually doing a face mill operation, it's almost always according to the stock that you have. But we've never had an option for choosing the actual stock. You always chose the part, and then you extended the boundaries a little bit, or drew a boundary, or did whatever. So what we've actually done now is we've actually recognized automatically where how much the boundaries of the updated stock. Now this will also guarantee the full coverage of the stock face at any stage of the machining. Now in face mill, besides that, We've also added one more little enhancement, is that at the depth, you can either set it by top of target, which we did not have before. It was always just user defined. No, we didn't have this field here at all. Now you can have it set automatically, and by default it comes on this way, by top of target, which is in most cases. So you normally start by top of stock and then go down to top of target. Let's actually take a look at actually what's going on over here. And I'll load my new part. Now this particular part you see here, you'll be seeing me using it pretty often on the during the webinar. I happen to like this one a lot. Okay, if I go into my face mill operation, you'll note by default now we have stock base boundary clicked. That is what is now, that's not what's being used now. And you'll note also there is no choosing of geometry. It goes according to the actual updated stock. I'm going to choose an end mill right now. Right now I'm just going to use a regular end mill because I have a specific issue that I would like to show everybody. I'm just going to use a regular 10 millimeter end mill. And as I mentioned before, in the levels, you see we have by top of stock as default and by top of target as default as well. Okay? The moment I write something in here, it'll turn into user defined. So if I write, let's say, 2 millimeters, you'll see it turns into user defined. Put it back to by top of target. It goes wherever the top of the target is. And of course, we have our step down. I'm going to leave my technology right now at hatch. And let's just do a quick calculation. And actually took a look at the top of the part, showing the stock. And you can see it covers the entire stock. You can also see the toolpath goes from one end to the other, exactly where it needs to go. Now, just to show how the updated stock actually works, I've actually created another operation here. And I suppressed it for now, but now I'm going to unsuppress it. And you'll note that this particular operation is before the updated stock, the face mill operation. You can see the actual stock that I have here now is a different shape. All I'm going to do now is put this back in the top view and just calculate this particular operation, just the face mill operation. And what you can see is that your toolpath has completely changed because now it's according to what the boundaries of the way the stock is right now. Okay, so that's completely, you don't have to touch the geometries. You'll also note that there is no geometry for that as well. Okay, for our next enhancement, we've made a major improvement in our chamfer recognition to be able to ignore chamfered edges. Okay, if you take a look at this diagram over here, you'll see that we have this face over here. We have all these sharp corners, but we happen to have a chamfer already over here. The same thing on these edges over here. But not only that, we have these edges over here where this wall is at an angle to here. And you may not want to put a chamfer on that. Now, previously, we've had problems doing this in chamfer recognition. We'll always pick up every single edge, no matter if I had a chamfer on it or not. And many times you weren't able to use this as well. So we've added the option of ignore floor wall wall angle less than whatever value you put in over here. Okay, now besides that, we've also added one more thing inside our chamfer recognition, is that we've added the option of having upper and lower levels as well. Why do we do this? There are several reasons. One, we can limit the depth, the lower level, in case we have an issue where we have a short tool. The tool is not long enough to go down to the bottom of the part. So now we can limit it as well. As far as the upper level goes, you may want to start a touch lower than the very top, because if I remember correctly, there are times where, for example, in electronic boxes where it's sealed on top by laser, they are not allowed to have any kind of chamfered edge on top. They have to be sharp. But the rest of the part, you may want to have chamfers over there. So you can actually start now a little lower as well. Let's take a look exactly how this works. Okay. As you can see, we have the part over here. I'm going to go into Chamfer Recognition. And we're going to define it. I always like, by the way, using 3D model protection. Very helpful. We'll just define our geometry. Now, normally beforehand, when we touch the part, what would happen is it would pick up every single edge, like you see. As you can see, it also picked up this edge over here. It picked up these edges around over here as well. And then if you put a chamfer on your part, it would actually ruin the part. So what we've done is as follows. Let me get rid of what I've done over here, unselect everything. We've added this little checkbox over here called Ignore Floor Angle Less Than, and as default, it's 90 degrees. Now if I click on the part, what you'll see is as follows. It picked up every single edge except for these chamfered edges over here, and this angled wall over here was also not taken into account as well. Let's just choose a tool let's just choose our chamfer drill that I read right now. I actually use this. I can use that or chamfer drill, doesn't make a difference. My levels. As you see over here, I can have my upper level and my lower level. By default, it's grayed out. But if you want, you can open it up and decide where you want to have your lower level. I'm not going to do that right now. My chamfer depth, I'm going to have a chamfer depth of 1 millimeter right now. And in my technology, exactly the way we worked before. No difference over here. Let's do save and calculate and a quick simulation of the part using Solid Verify. You'll see that every single edge has a chamfer on it. This edge was not touched, and neither was this edge. Now, let's say, for example, I do want to put a chamfer on this, even though it's a walled angle, but at the top they told me to break that edge as well. Not a problem at all. Go back to my geometry. Okay. I'll unselect all, and I'll just put the value over here of 70 millimeters instead. Now on 70 degrees instead. When I click on my part now, you'll see this time it took this edge over here, but did not take those edges over there. Save and calculate. Quick simulation of the part itself. You can see now that this was taken, but this was still not touched upon. This, by the way, will make chamfer recognition a lot more usable than it was before. In many cases, when people had parts like this, what they had to do was they had to not use chamfer recognition and do it in a regular profile operation. But now you can use chamfer recognition for this as well. Okay. Next. We've added the option inside our pocket operation to be able to use multi-tool, just like we did in iMachining 2D. Okay? Let's take a quick look. I'm not going to program the part. I actually have a part here that I've already done. I'll just show it to you for now. Here we go. Okay. I've actually created an operation using multi-tool pocket. I'm going to open it up. And as you can see, we have, of course, we have our geometries exactly the way it was before. If I go into my tool, you can see we have the exact same tool list exactly the way it is in multi-tool for iMachining. Now, technology goes over here, you have multi-tool or the regular pocket operation. In this particular case, like I said, I use the multi-tool. You can see my first tool over here and my second tool. Now, as I click on each one of these, we can see the different technologies that I have for each one of them. For example, T2, I have checked off over here, finish on the wall and the floor. Whereas T1, it's not doing any finish on the wall or floor at all. If I go into my levels or technology, is actually a good place where you can see this. You can see T1 is doing is not doing any wall or floor finish, whereas T2 is doing the wall and floor finish. And in the case of multi-tool, the control of these checkboxes is actually through the actual tool itself. Okay. And the result is obviously you have two operations created over here. Okay. Now, next, we've improved part synchronization with smart face geometry. Now, geometries are created using a smart face. Smart face is something that we've introduced in 2017. Will now give you more precise synchronization. For example, elements that were added or deleted from a shape of the face are now recognized if you used smart face geometry. Bosses added or deleted from the face will also be recognized. So, for example, if I have a part like you see over here, nothing on it at all, and then I change it, and I add a boss to it, and add these elements to it, it will now synchronize if you use SmartFace to create that geometry. This is something that we've had a synchronization for quite a while, but we've always had the problem of what happens if I add something to that face, because we always use chain geometries. The regular chain geometries were created by just recognizing the edges, but these edges were not here. But now when we do this SmartFace geometry, we tag the actual face, and we notice any change on the face itself, including bosses and changes to this area as well. Let's take a look exactly how this works. And I'll load that part. Okay. I'm just going to create a simple pocket operation right now. Okay. Creating the geometry. By default, we have smart face checked. I'm just going to click on the face, and we have one chain over here. And that's because of, and that was created automatically by a smart face with the open edge automatically recognized. Okay. I'll just choose an end mill that I want to work with. We'll choose, I'll choose this one over here. And my levels, I'll leave it exactly the way it is. My technology, I'm just going to have my open pocket using profile strategies, save and calculate. And you can see the actual toolpath that was created on the part. Okay. Now what I'm going to do is I'm going to actually open this part here. And I'm going to add the following. I'm going to add a boss over here. And I'm going to make a change to the actual shape. I'm adding elements to the face by adding this bossed area over here, this little step over here. I'm just going to save it. Synchronize. And just calculate. What you see now, the toolpath has changed over here, and now it includes the actual island that the actual stud that we have here, creating an island inside the geometry. If I were to go into the operation itself and take a look at the geometry, you'll see that we now have 2 chains instead of 1. Okay. Next. Okay. Now, last year we introduced drag and drop to a SolidCAM, taking a template, being able to drag and drop it to a specific surface or to a part, and getting the results from getting the toolpath automatically. Now, the problem was in certain areas, such as face mill or pocket recognition, drill recognition, and drill operations itself. Sometimes you would use what they call to create a geometry, not the typical model, but let's just take face, for example. You would say, I want to use the faces, just specific faces to create the geometry. And work only on those faces. So what we've added is that when we save a geometry, a template, we have the option over here called Include Geometry Filter. Okay? Let's actually take a look how this works. And I'm going to do a quick template on the part. I'm going to open up the part. Okay. Now, what I've already done here is I've already machined everything in these areas over here. Okay? We can see the updated stock. If I bring it down to here, everything over here was machined. And what's left are these bosses over here, still have material on top of that. And what I've decided that the way I want to remove these particular the material that's on these bosses itself is I'm going to use a regular end mill using a face mill operation, just going down the middle on those surfaces. Okay, just for demonstration purposes. Okay, now, so I'm going to go into my face mill operation, and instead of using this stock, I'm going to use the other part-based boundary. And I'm going to create my geometry. And my geometry this time is going to be faces. And I'll define my faces by clicking on this face, and this face over here. Okay. I'm also going to separate them so I can have it as 3 separate chains. I'll accept that. I'm going to choose an end mill. I'll use this one over here. My levels, upper level, this time it's going to be user defined up until this surface over here. As you can see, it's now user defined. And I'm just going to leave it right now at hatch, and that's it. Now, what I'm going to do is I'm going to go save my template. When I save the template, you'll note we have here, it says include geometry filters. This is besides the include tool data. We'll give it a name. Let's call this webinar temp faces. Okay. And we'll say okay. Now I'm not going to save this operation. I'm not going to save the operation. I'm not going to save anything over here. What I'm going to do is I'm going to actually use that template to create the operation. So let's make my list a little smaller over here. by typing in face over here, and here we go, webinar temp faces. I'm going to take it, drag it to this face, hold my control button on my keyboard, that one, and then this one, let go, and we now have the template using those particular faces over there instead of the entire part by capturing the filter that we used inside the geometry. Okay, now this option it can be used in other areas as well, wherever you have filters, such as Chamfer Recognition or pocket recognition as well. Okay. Now, two general enhancements I'd like to mention to you. One is that up until now, when you created your stock, you were able to create a 3D sketch of the boundary of the stock, but you were not able to create a model if you wanted to use a model of the stock itself. Now you can actually create a 3D model instead. Okay, and besides that, we've also added an option, is that for our CAM tree, we can actually customize it. Because sometimes people have always said that these lists are very, very long, and many times they don't even use some of the stuff over here. They'd like to actually have it shorter. So we've added a customize option, so you can check off whatever you don't want, and then you'll have a much shorter list. Let's actually take a look at both of these options now inside the program itself. Okay, if I were to go to my stock, let's go define over here. You see we have our box around the part. At the very bottom, we've added Create 3D Model. By clicking on that, what's actually happening is creating a 3D model. And as you can see, it created it also as transparent. So you can also always see through to the part itself. Now, where is this located as far as your SolidWorks tree itself? It's inside the CAM area over here. As you can see, we have the extruded boundary over here. Okay. Now, in addition to that, if I go to my operations, like I mentioned before, we have customized, so I can make this list shorter. But we don't only have it here, we have it in almost any list that we have a drop down to. So for example, add milling operations as well. I can also customize that. Let's say I'm a customer, I don't have any of these, so I don't want it to show up all the time. Okay, so I can just uncheck it. Okay, I'll have this, I probably will have that as well. Let's say I don't have engraving or translator or toolbox cycles, or I don't use toolbox cycles. Face profile, all these stuff I do use, this I don't use. Now if I click on this and go to add operations, you can see my list is a lot shorter than it was before. A lot more manageable for people who do not use those or do not have those options, so it doesn't show up all the time if you don't want to show them up, if they want to show them. Okay, now let's go on to the last subject of the webinar. iMachining. Now, there have been a lot of enhancements inside iMachining. I'm only just going to go over them briefly and only show you one of the options over there. The reason for that is very simple, because next week Anthony will be giving another lecture on all the features inside iMachining. So I just wanted to touch upon a little bit of an overview of what's going on over here and show you one of the options that we have inside there as well. Now, what iMachining actually does now, it actually makes the definition of your geometry simpler with new feature recognition technology. There are now several simple ways to define your machining geometry. To start, select the mode in which you want to work in. So we have basically 4 modes. One is called feature recognition by faces, by choosing a face, or feature recognition by chains. We'll get to that in a minute. We have also outside feature recognition, which is the one I'm going to actually show you a little later on. And we also have the classic way of the regular chains without any feature recognitions. Now, what we're doing with the feature recognition is very simple. We are recognizing automatically the stock, the combination of the updated stock and the target data, model data as well inside iMachining, in iMachining 2D. By doing this, it'll make it a lot easier, a lot more user-friendly. You'll actually also be able to see a lot more what's going on. Now, as I'm going along with this, we have the first one called feature recognition by faces. By simply, in this particular mode, clicking on a face will give you your geometry. And you'll also note that when you do that, you'll also get, it'll show you, give you a preview of what is actually going to be removed. Your upper level of the pocket will also be displayed with its value, as well as the lower level. Both levels are displayed on the part. Also, the smart chains build the smart faces builds the chain geometries. At the end of the day, it's a chain geometry built that uses the smart face to build those geometries. Now, in the cases where you have a through pocket, okay, or an open edge that you want to actually do an operation with, we have what they call feature recognition by chains. It'll do the exact same thing, except this time you're creating a chain to create your geometry. But you'll still get your updated stock, and it'll show you the preview of what's being cut. The next one is outside feature recognition. Outside feature recognition, when you choose this mode, it'll machine the entire outside perimeter of the part, and it'll go up until where the actual stock material is. In other words, it'll start from the outside of the stock that is in existence, up until the actual target. And in this particular case, there is no geometry that has to be even picked. You'll also show you the level detection. It'll show you the upper level and the lower level here as well. And of course, we have our classic chains. For those who still want to work with the classic way, but when you work in the classic way, you do not have the recognition and protection functionality that you have in the other modes. I'm just going to show you right now just one of these options, the outside feature recognition. And if I go into my program, I'm going to load. Actually, I'm going to use the part that I have over here. Good enough for me. Okay, so I'll go to iMachining 2D. These are what I've mentioned before. And I'm going to use the one that's outside feature recognition. And you'll see in that particular case, there is no geometry to be picked. I'll choose a specific end mill. That one over here, this one over here. Now you'll note also that it's showing you exactly what is going to be machined. Okay? If I go to my levels, it's automatically recognized as well. Okay? I'm just going to do simple save and calculate. And if we take a look at our simulation. Now use Solid Verify for the simulation. You see it's machining the entire outside perimeter of the part. Now, by the way, if you would try to do this in the old classic way, you would have to make your first geometry on the outside of the stock area and say that that was open. And your second geometry, your second chain would be almost impossible to pick. Not impossible, it would be very hard. Because if you note, there's no really one constant Z over here of the chain going all around. So you have to go from edge to edge. It was always a nightmare creating the geometry for this, for the outside perimeter. But now it will automatically recognize the outside perimeter. Okay, that's it for now. I am open for any questions you may have.
Looks great, Sid.
Okay, thank you. The microphones are open for everybody, so you can unmute yourself if you want and speak. Okay, like I said, this has been recorded. It'll be available later on. Harry, I see you have your hand raised. Okay, I guess not. I am muted. I'm sorry. Okay.
Hey, Sid. I was just curious, when you define the 3D stock model,
Yes.
what if the customer wanted to rotate it 45 degrees around Z and not put it on the way you had it, but wanted to, say, like, line it up with the edges of the part? Can you do that?
The actual stock itself?
Yeah, like, could you just take that block as you defined it, but rotate it 45 degrees and then accept it?
No. What you have to do is just, you have to create your stock that way.
Okay.
Now, Sydney, if you rotated your coordinate system 45 degrees and then went back into the stock generation, would it bring it in according to the coordinate system?
But you would have to rebuild it. Because remember, once you build the stock, you'd have to build it after you do that. Because once you build a stock, it's this particular model over here. It's just a regular model. It's just showing. It's not what the system is actually using for stock. It's just for you to see. So you would have to re-click on the part to update the actual stock. To update the actual model of the stock. Remember, that's just a model. It's not the real stock. It's just for you to visualize it a lot better.
Right, but to Harry's point, if we were to shift the x-axis 45 degrees around Z and then come back in and rebuild that stock.
Yeah, usually the box definition is based off
let's go over here. Let's
okay.
go over the system. Let's go open up everything so I don't have to go back and forth. Okay, if I go into my coordinate system, and we'll do an edit over here. Edit coordinate system. Click over here. Go down to the bottom. And rotate around Z. Say 45 degrees. Something like that. And accept that.
Yeah.
Okay, and we'll go into our stock. Okay, and we will okay, we have our stock updated actually. You can see the stock is actually going now this way over here. And now we have to recreate the stock. Okay, so now you have a new stock as a model.
Okay, perfect.
Okay?
Yep. Thanks, Sid.
No problem. Okay. All right. If there are no more questions, that's it. I hope you enjoyed it.
Sydney, we really appreciate you doing a special presentation for us, considering the timing and everything. That was really above and beyond. Thank you.
My pleasure. It was important that you guys heard the stuff, and that's why I did it.
Definitely, definitely.
All right. Take care, everyone. And one more thing. As usual, I always do this. Take care. Goodbye. Enjoy. Have a great day. I'll see you guys tomorrow.
See you, Sid.
Thanks, Sid. Thanks.
Thank you.
You're welcome. Bye-bye.